Everyone, I'm 1D. Today, section 8, estimation for the difference between two independent groups. Groups means populations, okay? We have dealt with one parameter so far. Now, it is a little difficult and new paradigm, I think, two populations problem. Okay, what is that? Okay, you listen this lecture and estimation of the confidence interval for the difference between two independent groups. Let us extend estimation of a single population to the problem of comparing two independent populations. Okay, we have now two population, population 1, population 2. So let us think about two independent populations be represented as x. One population is x follows mu x and variance sigma x squared. Second population represented by random variable y has mu y and sigma y squared. Okay, two populations. The difference between the two populations refers to the difference in their means, mu x minus mu y. Mu x is population 1 mean, mu y is the mean of population 2. So we like to know the difference, mu x minus mu y. Understand that? Then we will take a sample from population 1, x1, x2, x. Number of sample size is n1, x n1. And from here, population 2, we will take sample y1, y2, yn2, like this. Okay? Actually, it doesn't matter what is the distribution of population. So I didn't note any distribution, say normal distribution. So we don't have to worry about distribution of population 1 and population 2. Okay? We need to obtain samples from each population with sample sizes denoted as N1 and N2 respectively. That is X1 to XN1, Y1 to YN2. What is the best estimator for mu x minus mu y? It should be x bar minus y bar, right? Minus, and then best estimator. We now know the best estimator of parameter here, in this case, mu x minus mu y. Then we need to know its distribution. That distribution, x bar minus y bar, has normal distribution when sample size is sufficiently large. Okay? Then its mean is what? What is the mean of x bar minus y bar? It's going to be mu x minus mu y. Mu x minus mu y. What is the variance? Variance of x bar minus y bar is variance x bar plus variance y bar. We studied it, we saw it, chapter 2, end of chapter 2. If x and y are independent, then variance x minus y is variance x plus variance y. You have to know that. Okay, so sigma x squared over n1 plus sigma y squared over n2 is the variance. Okay, then it becomes to be simple because when we know best estimators distribution like this, especially normal distribution, then we have to standardize it like this. What is this? How do we call it? It is standard error of x bar minus y bar, right? And it is it follow normal distribution with mean 0, variance 1, and we start again. This standard form, the probability, this form, standardized one, minus g alpha over 2 plus g alpha over 2 is 1 minus alpha. We just follow when we have one population case. So we rearrange this equation to this one so that we get 1 minus alpha 100% confidence interval for mu x minus mu y. So a little complicated, but it is like a one population case. So x bar minus y bar minus this one, and x bar minus y bar plus this one. Okay? So even though we have two independent populations, the difference, confidence interval for the difference between them is like this. I think you may understand it easily. So confidence interval for is given by like this. Then can we use this confidence interval in reality and in practice? No way, because we do not know variance of population 1 and variance of population 2. Then how to do it? How to do it? We have to estimate it. But now, you have to keep in mind this part. When population 1, variance of population 1, sigma x square, and variance of population 2, sigma y square, is equal case, is not equal case. We have to divide these two cases. Then what is the case in my problem? The decision, which one is better, which one is right, the decision on which of these two used is determined through hypothesis testing. Next chapter, chapter 5. We will explain which case is better, which case is correct. Okay? So this case, two variances are equal case, two variants are not equal case. The result will be different. Understand that? Okay. Let me stop today's lecture here, because a little more important concept will appear. So I left the rest of this part next time. Okay? It becomes to be more complicated, but it is, I said, systematic, so you don't worry about too much. Okay, thank you. Bye.